Significant digits in chemistry are used both when we're reading measuring devices and when we're doing calculations that have measurements included in them. On the AP test, they'll allow you to be one significant digit off. So it's just a good practice of really counting your significant digits. Bottom line, in a measurement, the significant digit is all your numbers that you're completely sure of, and then that last uncertain estimated digit. Really, something that is not significant is a placeholder, and we'll see that when we move into these next rules. So there are several rules for significant digits, but if you can really remember two of them, then you'll see that it's pretty simple. Bottom line, if it is a non-zero number, then it can't be a placeholder, so they are significant. So when we look at the number 458, none of them are zeros, therefore they're all three significant digits. This is when we start getting into it. Now we're going to hit a zero. So when we look at the second rule, it says leading zeros are never significant. So leading zeros are all the numbers that are in front until you hit an actual number. So when we look at these are really just holding a place. If we took them away, the value of the number would change, but they're not measured. They're just placeholders. So because of that, this 458 is what's significant. So embedded zeros are not placeholders, so therefore they count. So that's why in this number, 4,000 or 45,008 centimeters, all of them are significant because those zeros are not placeholders. These zeros right there are not holding a place, so they count. They would, if you took them away, I mean, our value would really change, but they're not holding a spot. So therefore, that has 5 significant digits. So again, when don't they count? Well, so far, the leading zeros. So leading zeros, always say the leader of the pack. Those zeros don't count. And then there's only one other time they don't count, and that's your trailing zeros. So trailing zeros are significant when there's a decimal. So the first thing I look at is if there are trailing zeros at the end of the number, is there a decimal place? If there's a decimal place, they count because they're not really holding a spot. They're actually measured. I don't need those 2 zeros at the end, but they show accuracy in my number. But if I look at this number, 458,000, these are just placeholders. And what do we know about placeholders? They don't count. So this is why this 458 has 3 significant digits, where when we put the 4,580 with the decimal point and the 2 zeros, those don't have to be there. They're there to show accuracy, so everything counts. So a little trick that I do then is when I take a look at a number, the first thing I look at, so let's just make up a number. So 5, 6, 7, 0, 0. First question, is there a decimal? If there is no decimal, I look at the back. So I see that these 2 are just placeholders. This would have 3 significant digits. So I just call them sig digs. If I have another number, 5.670, I see a decimal, I don't look at the back. I look at the front. I don't see any leading zeros, so everything counts. So there are 4 significant digits. So what if there's 0.00730? So what do I look at? Decimal, front doesn't count. 3 sig digs. Now, the other thing for significant digits that we need to look at are numbers with exponents. And so exponential or logarithmic numbers that have like 10 to the whatever, those are really just placeholders. And so if they're written correctly, so if a number is written in the correct scientific notation, then everything other than the 10 to the whatever counts. So if I look at this, there's 3 sig digs. Now what do I mean written correctly? So if I have this 0.05 times 10 to the 6th, that is not written correctly, because written correctly means I can only have one number to the left of the decimal. I can't have this 0.0. So if I moved over to that way, I'm going to have 5 times 10 to the 4th. Now, the other thing that we need to look at in significant digits is what do we do with them. So whenever we add and subtract numbers, we don't look at significant digits. We actually look at the number of decimal places. Your answer is like your weakest link, can have the least number that's in your operation. So for example here, I have 15.21. I have 4.5. I have one decimal place, so therefore my answer can only have one decimal place. This works for addition and subtraction. So in multiplication and division, you look at your least number of significant digits. So in the example, 2.0 has 2 sig digs. 2.04 has 3 sig digs. My answer can only have 2 significant digits. It's the weakest link. So I have to be able to round. I know that that's 0, remember, at the end. So no decimal, back. If there's a decimal, you look at the ones in the front not to count. And so that's going to be not significant, so there'll be 2 significant digits. So your answer can only be as accurate as your weakest number. Now, when there's a combination of addition and subtraction and multiplication and division in your number, you do the operations and you round them as you go. So that's significant digits.